today's topic is the expression for resistance when they are connected in parallel. In the last lecture, what we discussed? In the last lecture, we derived the expression for resistances when they are connected in series. And yesterday's video, if you want to see, you just click on the link which is given in the description below. Okay, that is for expression for resistor when they are connected in series. This is the diagram for that already I draw here. So that is for resistors when they are connected in parallel. Here there are three resistors are there, R1, R2 and R3. So these three resistors, they are connected to each other, and ammeter is a device used to measure the current in a circuit. One more, that is what V stands for voltmeter. It is used to measure the voltage, also called as to measure the potential difference. Next one, we have to use one more, it is what key, and this key is used only for on and off purpose. Right now the position is on. It means that there is a flow of current, and the flow of current we always denotes with the help of the conventional flow, that is from positive to negative terminal of the battery. And here to apply the potential difference for as a source of current, we used here the cell, that is denoted by the symbol called E. And arrangement, if you observe, this arrangement is for the to find out the expression for the resistances when they are connected in parallel. Okay, so this is what the description of the diagram. Now it's time to derive the expression, and for the reason we have to know the two mandatory conditions. We have to know the two mandatory conditions which are very important here. जैसे मैंने आपको सीरीज में बताया था, in series there is like same current flow through the resistor, and potential difference is nothing but we have to find out the sum of the potential differences. Why? Because it is drop across each resistor. वही रिवर्स कंडीशन आपको यहां पे मिलेगी. In parallel the potential difference across each resistor is same, and you have to find out the value for current, and here the current is different. Why? Because current flow through each branch you have to calculate here, and for the reason sum of the current is nothing but the equation number 1 in case of the resistance when they are connected in parallel. So as the potential difference are the same, so no need to calculate, but you have to calculate the sum of the current. Let I1 is the current which flow across R1, I2 is the current which flow across R2, and I3 is the current which flow across I3. Suppose you have to find out the sum of current across the point C and D. So what we have? We have the formula I equal to I1 plus I2 plus I3. It is called equation number 1. Sum of the current across each branch is nothing but the total current. Is it? So this is what called as the equation number 1. Now it's time to derive the expression. So we have to use, जैसे हम लोगों ने सीरीज में फॉर्मूला यूज किया था, same formula you have to use in the parallel also. And what is the law we applied here? We use Ohm's law. And Ohm's law, the current flowing through a conductor is directly proportional to potential difference applied across its two ends. We have one more video on Ohm's law, so you can follow just my videos to observe what exactly the Ohm's law says. And in short, we derive the formula V is equal to IR. This is the formula for Ohm's law. We just rearrange for I. अगर I को लेंगे तो क्या हो जाएगा? It becomes V upon R. Suppose we take R on the left hand side, it becomes V upon I. So here in parallel we have the use formula I is equal to V upon R. So यहाँ पे मैं लिख सकता हूँ but using Ohm's law, what we have? We have the I is equal to V upon R, comma I1 equal to V upon R1. Why? Because I1 is the current which flow across a resistor R1. In the same manner, I2 is equal to V upon R2, and last I3 is equal to V upon R3. So we have to put up all these value in equation number 1. Now question ऐसे आता है स्टूडेंट की तरफ से, why we are not taking like V1 upon R1, V2 upon R2, V3 upon RT? Because here this is the condition, potential difference across every resistor is same. That's why no need to take V1, V2, V3. Is it? Now put up all these value in equation number 1. So instead of value of I am replace this I with V upon RP. What RP? R stand for effective resistors. P stand for when they are connected in parallel. When they are connected in parallel. Second, for I1 we put up the value V upon R1 plus for I2 we have to put up the value V upon R3 and I3 equal to V upon R3. So this is what, after putting this value, respected value of I1, I2, I3, we got this equation. As the potential difference is same, we can omit that. So if we just remove this V from here, so what happened here? 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and this is the equation for the resistors when they are connected in parallel. When they are connected in parallel, is it?